Hey everybody! Today we are going to be working on a quadratic word problem, and this time the type is going to be projectile launching. There's a little bit of background information that I'll hope folks have. As prior knowledge, you should be aware of how to calculate a vertex of a quadratic and the x-intercepts. Now, I'm still going to go through the steps, but you should be aware of what those are. So let's get started. A ball is thrown into the air according to the following equation, where y is height in meters and x is time in seconds. And we're given our little equation here. It's y equals negative 5x squared plus 25x plus 2. Typically, a part A question for this would be, when is the ball at its highest point? When is the ball at its highest point? Because this is asked for when, we know that we're looking for a time. So we're going to be looking for an x value. And because it is said the highest point, we know we're going to be looking for a maximum. What this means is we're actually looking for the when, the x value, at the highest point, the maximum, which is the vertex. In order to get the x value of the vertex, we use the equation x equals negative b over 2a. X is equal to our b value, that's the number in front of the x, so a negative 25 all over 2 times our a value, that's the number in front of the x squared, so a negative 5, and we chug this out and we get x equals 2.5 seconds. And that's the answer to the first part. But, of course, we're going to increase the difficulty here. We can't stop there, so let's move this up, and we're going to add a b part. And our b part is, how high does the ball go? How high does the ball go? How high is asking a height. Because we're talking right now is how high does it go, that's a maximum height. Max height. And a max height is our vertex. Well, we've already solved the x value of our vertex, so to get the y value of our vertex, we actually just fill in that 2.5 seconds that we solved previously in for x. What we're going to end up with is y equals negative 5 multiplied by 2.5 squared plus 25 times 2.5 plus 2. We've just filled in the x value of the vertex into the equation. This is going to give us the y value of the vertex. Y is equal to, we're just going to clean this up, negative 31.25 plus 62.5, so that's multiplied, plus a 2, and our y is going to equal 33.25 meters. And that is our maximum height. Anytime we're talking about maximum, you know that we're talking about a vertex. When is it the highest? How high did it go? Always a vertex. In the next question, you're going to see how that changes, that we're not going to be looking at the vertex anymore. So in the C question here, it says, when does the ball land? Landing is not a vertex. It's no longer the maximum value. It's actually when the ball hits the ground. That's our zeros. And if we were just to draw a quick little side sketch of this, you're going to see that it looks something like this. And that's where our ball hits the ground. Right there's where our ball hits the ground. In order to do that, we have to solve the x-intercepts. How do we solve the x-intercepts? Oh, one of my favorite little equations, and we're going to actually do this out the long way to get some practice. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where our initial equation, just so that everyone remembers, is y equals negative 5x squared plus 25x plus 2. So our a value equals negative 5. Our b value, the number in front of the x, is 25. And our c value is 2. So we can fill these in to our quadratic formula, and we're going to get x equals negative 25, our negative of our b value, plus or minus the square root, big ol' square root there, of 25 squared minus 4 times our a value, negative 5, times our c value, 2, all over 2 times our a value, negative 5. Now, I'm going to do this in a few different steps. I mean, you can do this as fast as you want. I'm just going to show some work here for those that are really trying to understand what we're doing in these steps. So we end up with x equals our negative 25 plus or minus, I chug out all of this underneath the square root, and you're going to get 665 all over negative 10. I'll move this down a little bit so we can get some more space here, and clean this up a little further. We're going to get x equals negative 25. I take the square root of 665. We're going to approximate that because it gives us a decimal. Leaves us with 25.79 all over negative 10. At this point, we're going to deal with this plus or minus. It's going to give us two different answers. We get the negative 25 plus 25.79 all over negative 10, and we get the negative 25 minus 25.79 all over negative 10. Again, this is x equals and x equals. When you work these out, you're going to get two separate answers. You're going to get x equals negative 0.079, and you're going to get x equals 5.079. When you look at these answers, one of them is wonky. That is because this negative is impossible. The ball cannot land backwards in time. Cool as that may be, we are going to discard that answer and accept, I'll put some little s here for seconds, that our ball lands at 5.079 seconds. Yep, see? Pretty cool. We were able to figure out when our ball lands. One last part that I'm going to add on here. We'll undo that. We don't want that there. We want to try one last part, and it's going to be our D part, and it's going to say, when is the ball 20 meters high? When is the ball 20 meters high? Well, we're talking about height again. Height is our y value, and it's 20 meters. So if I write out that original equation again, so y equals negative 5 x squared plus 25x plus 2, because we've been asked when it's 20 meters high, that means y equals 20. This becomes 20 equals negative 5x squared plus 25x plus 2. Oh, well, we have that set up, but is that really helpful? It is. We've been asked when. We've been asked when. That means it's looking for a time. We're looking for a time, which means we are solving for x. In order to solve for x in a quadratic, we have to set it equal to 0. So that means subtract 20, 0 equals negative 5x squared plus 25x minus 18. This looks awfully familiar. We're doing it again. We're doing it again, because this time we have an a value equal to negative 5 and a b value equal to 25, but our c value is negative 18. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Anytime you want to solve for an x value, if you have been asked to solve for the time, you are going to this equation right here. So let's go ahead and fill in some values. X equals the negative of our b value, negative 25, plus or minus the square root of 25 squared minus 4 times our a value, which is negative 5, times our c value, which is negative 18, all over our 2 times our a value, which is negative 5. Now I'm going to clean this up a little faster this time rather than showing all the steps. It's going to work out to become x equals negative 25 plus or minus 16.28 all over negative 10. You're going to work this out and you're going to get two separate answers. X equals negative 25 plus 16.28 all over negative 10. And you're also going to have x equals negative 25 minus 16.28 all over negative 10. We get two answers. X equals 0.872 seconds, and x equals 4.128 seconds. Now hold up here a minute. In the last one we were able to cancel out one of these answers, but these both look positive. How do we know which one is the correct one? Well, if I scroll this up, and we can see our two answers here, our 0.0872 and our 4.128. They're actually both true. They're actually both true, because if I again draw a quick little sketch here of what this could look like, and it kind of looks something like this, we knew that our highest point that we went to was 33.25 meters. So when was it going to be at a height of 20 meters? Well, it actually hit there twice. It was at 20 meters once going up, and 20 meters again coming back down. So that means both answers are correct. And that is how we solve a quadratic word problem that involves projectiles. I hope you enjoyed the video. Thank you very much.